In this video, we're going to talk about analyzing and displaying categorical data. First, let's actually define what statistics is. And spoiler alert and a fair warning, there are a lot of new vocabulary terms at the start of this course, so buckle up. Statistics is the science and art of collecting, analyzing, and drawing conclusions from data. So that's what we're going to do this year. It's exciting. So the first part of that definition of statistics is collecting data. And so when you collect data, that's great. You need to display that data. And so there's a lot of different ways that we display data. Most commonly, it's in some kind of chart. An example is here. And there are two major things that are going to be in your data table. There's an individual, and then there are variables. An individual is an object described in a set of data. They're things, normally people, places, animals, things, an individual. And a variable or variables are the attributes of those things. So the different values for different things, or people, or animals, or places. So for example, this data set, this data table, has things about a household here. So the household is the individual. That's the thing that we are collecting data on. And the variables are region, number of people, time and dwelling, yada, yada. So that's the information or the varying things, hence variable, about that individual that we have collected information on. We can dig even deeper into variables, and there are two different types of variables that you can collect data on. So remember, we collected information about an individual, for example, a household. And so you can have categorical variables that you collect. And so those assign labels that place each individual into a particular group called a category, hence categorical. So those typically aren't numbers. That's usually the biggest giveaway. So for example, here we've got region, time and dwelling, which has a little star next to it. We'll talk about that in a second. Response mode, and do they have internet access? So those aren't numbers except for time and dwelling. Those are just categories onto which those households, for example, can fall into. So the other variables are quantitative, and if you know what that word means, you know it has to do with numbers. So quantitative variables takes number values that are quantities, which are counts or measurements. So that would be number of people in a household, household income, and coming back to time and dwelling, and you're like, yo, wait a second, those are numbers, but here's why that's a categorical variable in this circumstance and not quantitative. So there are numbers, but it's categorical because there are ranges. So 2 to 4 instead of just 3, or 10 to 19 instead of just 15. If those were recorded to the nearest year for each household, so if they were all single numbers, then they'd be quantitative. I know, it's picky, but now you know. And just expounding on that point a little bit more is that not every variable that takes number values is quantitative. So that would mean that because they have some numbers, that doesn't automatically mean that it's a counted thing. So for example, zip codes. Zip codes are numbers, but they don't actually count or measure anything. They're just a number assigned to a place. So that would be categorical instead of quantitative. So something that our book says that I really like is to make life simpler, we sometimes refer to categorical data or quantitative data instead of identifying the variable as categorical or quantitative. So the next step after collecting data is to display and analyze said data. And something that we look for in variables, so remember that's the data that we collect on individuals, and we're looking for the distribution of that data or that variable. So what does it look like when I put it into a bar graph or a dot plot, for example? So that's just what the data looks like, and we'll talk more about distribution later on. So let's take an example of analyzing categorical data. Let's say that I've got 10 data points on preferred communication method from 10 randomly selected students in a study. They're Canadian, if that makes any difference. So here's what they chose. We've got a couple of in-person communication, cell phone, Facebook, text messaging. So let's take these 10 random data points and summarize the distribution categorical variable. I know, you're excited. Hold your horses. So we've seen a table already, but I want to talk about two different kinds of data tables and how you can represent that data. So these are both what we call frequency tables. One of them is just a straight up frequency table, and that shows the number of individuals having each value. So for example, the number of people who said cell phone was 2, Facebook was 1, etc. Then there's something called a relative frequency table that shows the proportion or percent of the total. Remember, there were 10 people who answered that survey. So for example, the frequency table would tell me 2 people said cell phone is their preferred communication method, but a relative frequency table tells me 20% or 2 out of 10 or 0.20 of those respondents chose cell phone. So same data, just 2 different ways of displaying that data, depending on what you want to do with it. And also just to note that the frequencies, so the number of people and the relative frequencies listed are not data. So the thing on the previous slide where we had all the answers listed out, that's data. I know, it's words. So what can you do with those frequency tables? Well, you can display your categorical data. For example, you can create a bar graph or a pie chart. Now, I'm absolutely sure you've seen these before. In fact, you may have made them in some form before, but I really want to talk about the statistical significances of both of these. So the definition of a bar graph, it shows each category, those variables, as a bar, hence bar graph. The heights of the bars show the category frequencies or relative frequencies. So for example, cell phone is 20%, so it's 20% over here. Facebook was 10%, etc. And a pie chart, right, takes a circle and chunks it up into those relative frequencies as well. So text messaging is the largest chunk there, it's 40%, and then in-person is 30%, etc. So obviously these two represent the same data from this relative frequency table, but 2 different choices as to how you display that data. So of those 2 graphs, the bar graph and the pie chart, I want to focus on how you make a bar graph. Now, I'm sure you've made one before, like I said, but you got to get all those details in there if you want to make a really good, statistically accurate bar graph. So 3 major things. 1, draw and label the axes. Those are really important, and we'll talk about which one you put where. Number 2 is to scale the axes. The scale on both are really important. You can have a different scale on the x-axis and the y-axis, but you have to make sure the scale on the x, for example, is the same throughout. You start from 0 on both axes. It's really important. I'm sure you know that, but just reiterating it. And then you want to draw your bars above the category names and make sure their width is the same. You can make them different colors. You can put in different patterns. You do you. All right, let's take a look at this example. What's on the radio? So a rating service categorized U.S. radio stations in terms of the kinds of programs they broadcast. The frequency table summarizes the distribution of station formats in recent year. So we've got adult contemporary, we've got country, oldies, religious rock, Spanish language, etc. We've got our number of stations here. We're going to turn this into a bar graph. All right, here we go. I've got my blank axes here. I've got an x-axis here and a y-axis here. So this is the individual. Format is going to go down here on the x-axis, and number of stations is going to go here on the y-axis. I'm going to attempt to label them. Let's see how it goes. Okay, so I cheated a little bit and I typed out the individual and the variables instead of handwriting them, because nobody wants to see that. So down here on my x-axis, I've got my individual, I've got my radio station format, and I listed out all of these stations, and I did it at a slant because of space constraints. And then over here on my y-axis, I've got my number of stations, and I started at 0, always start at 0. And then I decided to count by 500 because that's what fit. So scaling the axes, we've done that already. Notice that the scale here, everything's pretty much scaled out. They have the same amount of area, and this scale, whenever you're doing numbers, obviously, you want to make sure that scale counts by the same number and starts at 0. And you want to make sure that you can graph all of your data. So the largest number that I'm working with is almost 5,000. So 0 to 5,000 makes the most sense. So now I'm going to draw bars above the category names. That'll do by hand, and you can see what I'm talking about. So let's check that out. All right, forgive me, I cheated again. These bars look so much better than what I can make with my hands. So what I did is I matched these bars, which are all the same width and relatively the same space apart. Like, forgive me, again, I kind of did this by hand, but I digress. So what I did is I matched the number here. So for example, adult contemporary was about 2,500. So the height of the bar is about 2,500, and then went down the line. And as you can see, all these bars are a different color. You don't have to do that, but when you have the capability, why the hell not? If you want to pause the video and take a moment and look at all of the data here, it might surprise you, or you might have some assumptions about the demographics in which they recorded this data from, but I digress. So we did the last thing, draw bars above the category names. Again, make sure that they're evenly spaced, they're the same width. You can make them colorful or not, up to you. But that's a beautiful bar graph, if I do say so myself. And here we have a pie chart, totally stolen from the textbook, because a pie chart is far more difficult to create by hand. So there's a lot of different technologies you can use to make a pie chart. We'll make some, certainly. But please note that a pie chart must include all categories that make up a whole. Otherwise, you don't get a full circle. And obviously, they are proportional by their percentage. Or you can put the number, but typically pie charts have the percentage. So for example, other formats is about 19.1% of the total. And note that the individual, so the radio station format, is labeled somewhere out here, and then each of the different slices or the variable here are labeled on each of the slices. One last word of caution before we end this video. One is to beware of pictographs. So a pictograph is very similar to a bar graph, but instead of using bars, they use pictures, like this Mac here, or Windows, or not a computer, although it's a computer. So they're very eye-catching and dramatic looking, but they're not the most accurate things. So beware of using them, beware of reading them. For example, this one has to do about previous computer ownage, and that is no computer, a Windows, or a Mac. And I think they're trying to convey that a lot more people had a Mac that they surveyed, but I would definitely just go with a bar chart instead of a pictograph. And the last thing I want to talk about is a misleading scale. So our tried and true bar graphs down here, they're almost the same. They represent the same data, except one scale starts at 0, which, as you now know, you should always start at 0. And then this one just starts at 10, just 10. Like, what could that really do? I mean, look at the differences between these bars here, where PCs are, a little above 10%, and no computers is almost 20%, but it makes it look almost non-existent as far as a PC or no computer goes. Whereas you want to make sure that you are displaying all of the data, not just like that, wow, a lot of people had Macs before. You want to make sure that you are displaying all the data. You want to make sure your scales are the same. You want to make sure that you start at 0 and your bars are the same width. Equality for your bars, your bar graphs. That's going to do it for this video. Thank you so much for watching.